Okay, so we have here
We've got the RG record player.
RG.
Yes, RG1 record player with the reference tone arm and Miyajima Madake cartridge.
Yeah, that's a really nice cartridge. Okay.
And this is going through the FM 122
Okay,
phono
FM
stage.
Acoustics, right?
And next we've got a SG record player with an SG tone arm and the Hyperion OCL.
Okay.
That's also going through the FM, another FM 122.
Okay.
This one is the new baby deck, which is the MG. Borrows quite a lot from the SG in terms of bearing and motor, pulley and so forth. It's also using the SG tone arm with the Audio Technica Art 9 cartridge. This is going through a prototype phono stage that we'll be bringing out in the next 3 months.
Okay.
That would be quite an entry-level one. It will be retailing around £500.
Ah, so give me the prices of all.
The RG record player is 17,500 UK. Reference tone arm with the HP tone arm cable is 27,000. The Miyajima is 3,750.
Right.
SG1 with the power supply, I think, is 12,500. The tone arm is £2,000. Hyperion is £5,000.
Okay.
The MG with the tone arm with the power supplies is 6,500 together, and the phono stage would be about 500, and the cartridge is £800.
Right, that's a relatively inexpensive but good cartridge. Okay. And so what does the FM Acoustics cost these days?
FM Acoustic, the 122 is around 8 tone arm, you mean? Or
The whole thing, the arm and the table.
Okay, the tone arm was done first, as you know, because I seriously thought the weakest link was the tone arm. It has, there are several materials and things used, but geometrically what it has a pivot point in the horizontal direction, which is about an inch above the pivot point for the vertical direction. This is mainly to do with the low frequency cut that is lateral and mono, and as it go up it becomes stereo. So for the tone arm to be stable at the low frequency cut sideways, which always changes the harmonic structure above, even if you don't have systems that they go very low, sometimes you play things, you think timing isn't quite good, but if you go to a system that goes low, you hear all those very low notes coming. They're the ones that are upsetting the tone arm. But also, because the tone arm doesn't need to constantly rotate, the bearing needs to go only from here to there, and only up and down by about 7 degrees either way. So rather than using sliding surface, where you get stiction, because every time as the tone arm is constantly doing this, it's stopping and then moving this way, stopping, moving back, and stopping up, going down, stopping down, coming up. Every time it changes direction, you need twice the friction to move the arm. But the arm doesn't know where to go. It's always the suspension that gets compressed first, then pushes the arm out. Now, by using a polymer metal film rather than a sliding bearing, so this film is just basically doing this, you have no noise and you have no stiction. So it has constant friction in all directions. We also apply the anti-skate by a few microns thick film of silicon. So it has no resonances in it. It's a pain in the neck to actually cut it small, but it sort of profiles around the back here.
And can you keep the torque constant throughout the play of the side of the the anti-skidding?
Yeah, it's profile, so it's coming around a metal part like that. So it's changing direction, and then when you're getting towards the back, it's increased already, but then moves only sideways. It doesn't pull anymore. So you get the profile that you want. So the anti-skate is lower at the outside and gets increased on the inside, but then it tailors off.
Okay.
And also the counterweight, we're using the same principles as before. So you articulate it sideways and you articulate it this way. Because the center of gravity is lower than the bearing point and it's in line with the stylus tip, any pull on the stylus, it doesn't push the arm up or down. But if you have a warp record and the tone arm is doing this, the pivot point is through 2 precision ball races up here. So as the arm goes up, the distance from the counterweight to the bearing slightly increases. And as the arm comes down, it reduces. So you're tailoring your tracking weight to, as the record leaves the cantilever suddenly, the tracking force is increased. So you minimize the deviation from where you should have been. So you hardly hear the warp problems on the thing. When it comes to the arm tube and the head shell, they're machined from titanium, the 2 pieces. But titanium has a property of self-fusion. So if you have a certain interference between the 2 parts, as you push the item together, it actually fuse welds. So you don't need glue, you don't need screw, you don't need anything. So it becomes one piece. And then you have aluminium alloys, you got stainless, tungsten carbide, etc., doing all the rest of it. Comes with a little feature which is actually battery operated, so it has no effect on the thing. Then you can actually switch the light off, switch the light on, dim it, bring it up.
Just for fun.
No, it actually does help. I mean, especially when you're in places like this, you don't have a
yeah.
light on the thing. It does help a little
Yeah.
bit. Yeah. On the record player side, it's basically a 4 plinth design. The top plinth is rigidly linked to the stainless feet, so this is solid. But hanging from the top on 6 bobbins, where each of them have got 2 different tensioned silicon bands, they hang the bottom plinth. And then decoupled from the bottom plinth is the middle one, and decoupled from the middle one is the sub plinth here. The bearing housing, unfortunately, I don't have one to show you. It's unbelievable. This one uses a tungsten carbide spindle and aerospace grade phosphor bronze. Gap between the 2 is 2/10,000ths of an inch. So the oil, and we formulated the oil in England with one oil guys, very good. They have got, we added anti-friction, anti-foaming as it's spinning. Sometimes you get foam bubbles coming. It's anti-foaming, water repellent. So even if you had in high humidity places, the water actually comes out of the oil. And it's got a coolant accelerator. So the tip, which is the only place that is contacted, it gets rid of the heat quite rapidly. On the motor side is the same as what I always done with motors, trying to keep the belt tension constant. Because constant belt tension will provide uniform torque onto the thing.
Absolutely, that's always a problem.
And also, you need to allow the inertia of the platter dictate the speed and not the motor.
Right.
So if you look at the motor, which is positioned inside an aluminium tulip, is between 2 precision ball races, and it's also got an acetal ball which goes against the spindle of the motor to hold it floating rather than hitting the bushes.
Right.
And even if you move the suspension, you can see that the motor begins to react to it.
Oh, yeah.
Yeah. So the motor will react, which keeps the belt tension constant. So rather than the belt putting force onto the platter, the force goes into this section. So, you know, as I say, even if you do that, or if you slow down trying to slow down the thing, it immediately comes to keep the belt constant. And the trickle of the energy is the bit that you keep adding to the inertia. It's also a 48-pole motor. So it's a smoother and it's synchronous, and we even cut the crystals for 45 to make sure that it is correct at that speed. And the pulley is very accurately machined.
So is it adjustable, or you just lock it in?
No, it's locked in. I am planning to do one with adjustable, but not infinitely adjustable, giving you quarter
Right.
You know, 4 on either side,
Yeah.
doing 1% this way, 1% that way. But as you know, when they cut the records, they're relying on mains frequency.
I was gonna say.
And that is up and down over during the day. They just guarantee over 24-hour
And
period.
there were
that the-
tapes running at they were run at the wrong speed when they cut the
after
records.
the war, I was talking with Miles from Abbey Road, and
Yeah,
he was-
I an email with him.
yeah. He told me after the war, because there was so much load on the machines and the generators, they deliberately slowed down by a few percent, and at night they speeded it up to be within the law,
Wow.
to be 50 hertz
Right.
over 24-hour period. And he said none of the record companies knew. So in the morning they're cutting these things. It's a bit wrong, this is a bit slow. Why is it like this? And then they found out later.
How many years did that go on?
No, it's just into the
Right after
late
the war.
40s.
Yeah,
Just
yeah.
right.
Okay, that one-
I mean, once they got the constructions and
Yeah,
things sorted,
yeah, yeah.
then the load was much less.
That's funny.
That's really.
But then
funny.
there was like the Rolling Stones Beggars Banquet that was cut at the wrong speed because
Yes,
the tape was wrong.
yes,
and
yes.
Kind of Blue was originally cut at the wrong speed.
Yes, yes.
There you go. Okay, that was great. I really appreciated that.
Thank you.